So like think of this number as x1, this is y1, number 12, x2 and y2. You want to give that a shot, working that out?
Yeah. So -6/6, which would be -1.
Yes. Very good. You got to remember the formula. Do you get a reference sheet or note card or anything on the test?
Yeah.
Oh, you do? Okay. This would be good to go on there.
Yeah.
Okay. Can we move on to 13?
Yeah.
All right. So I don't know much about you. Do you play any sports? Do you do any kind of extracurricular activities, stuff like that?
Yeah.
What do you play?
I play volleyball and I box and just go
Oh,
to the
cool.
gym.
Nice. You're a workout guy. Okay. Awesome. Okay. So let's talk about that. So a new gym is about to open and the one-time membership fee of $120 is being reduced by 30%. Okay. What is the discount? How much will you pay? This is kind of like number 13 there. Okay. So you've got to figure out two things, the discount, and then like, how does the discount affect that membership fee?
Yeah. Like the new cost.
Exactly. Exactly.
Reduced by 30%. So far I've multiplied yeah, I got like 1,600 and then
Ooh, that way too big here. So quick
because
review here.
I multiplied by 30.
Yeah, but you're still really far away because even multiplying by 30 is going to be the same number. It's just gonna be off by digits here. You should have gotten,
1,000%.
yeah, that's better. So it's 0, 6, and 3, and then you move the decimal over 1. So $36. And that's the discount. What is the new price of the membership fee? It was originally 120. This is the discount. That's what's marked off. How do you find the new number?
Do we subtract
Yes.
120?
Yes.
So 240.
Say that again.
240.
No, you're subtracting. 120 minus 36.
I thought it was 306. Oh,
You got to move the decimal over.
so yeah, 74.
7. Yes. No, 84. 84.
Sorry.
Okay, let's consider another way to do this problem because I'm not sure that this way worked out real well. 10% of 120 is 12. Do you agree with that? 10%, you just move the decimal over once.
Yeah.
So 30% is multiplying by 3. 12 times 3 is 36. All right, so that's, you can always multiply, but then you have to deal with the decimal.
Uh-huh.
So it's up to you. I mean, it's totally up to you. There's two different approaches here. Doesn't matter to me. You got to find the one that you like. You got to say, okay, I like the way on the left, I like the way on the right, and that's what you're going to do. Should we do another one like this?
Yeah.
Okay. We'll just keep it really simple. I want you to determine 40% of 580. So you can either multiply 40% or 0.4 580, or find 10% of 580 and multiply by 4. Both will work. Both give you the same answer.
So 40% of 500. Oh, wait.
Yeah, so you're either multiplying by 0.4 or
Like 23.2. Or did I do the
it,
decimal
it
wrong?
it's a nice, this one's a nice number. Meaning there's no decimals. It just comes out really nice.
Yeah, okay. It's because I did it without moving the decimal first.
So did you do the one on the right here?
Yeah.
Okay, so you multiply without the decimal. You're like 4 times 0 is 0. 4 times 8 is 32. 2 with a carry of 3. 4 times 5 is 20 plus 3 is 23.
That's what I got.
And then you move the decimal over once because there's one decimal place here. Maybe that was what was unclear. The number of decimal places is how many places you move over the decimal. So the answer is 232. Is that okay?
Yeah.
That's the discount. Let's just consider that the discount. What is the new price? So take this original number and subtract the discount to get the new price.
$348. Wait.
Yep, that sounds right.
Okay.
All right, so just because I don't think we've got enough time to do everything, maybe look at those notes again before your test. So 15 is really two questions. 15 is the slope of a horizontal line, which we already know. The slope of a horizontal line is always 0.
Mhm.
The other one you have to know is for a vertical line. Slope of a vertical line is undefined. Or no slope.
Huh.
You have to know both of these. This might be good to put on that note card.
Yeah, I will. Yeah.
All right, so we can move to 16. Okay, let me know when you're ready for that.
Yeah.
All right, so you're a gym guy. Give me a target at the gym, like either a weight thing that you're doing, lifting, or like a, you know, give me something you do at the gym that's, or boxing, like.
Like a squat PR or something.
Okay, so what's your squat weight right now?
205.
205. Okay. And let's say in the next month, we want to get 120% better. I know this is unrealistic, than 205. I'm just trying to give you a different number than just something random here. So you have to take this percentage and multiply it by 205.
Uh-huh.
What is this percentage as a decimal? If you're not sure,
2.
here, 40% was 0.4.
So 1.2.
Yes, yes. And that's very important because that's what you're going to multiply this number by.
Uh-huh.
So ignore the decimal, just multiply it out. Move your decimal over left 1. When you're done.
So is it 24.6 or 20?
So remember, it should be bigger. Like when you want to go up in weight, it's bigger here. So
Oh, so 246.
yes, that's your new weight.
Yeah. Oh, I see what I did wrong. It just I moved the decimal and I didn't count the 0.
Yes.
There you
Okay. All right. So you're going to get some sort of decimal multiplication. Yeah, you'll figure that out here. Okay. Let's do one like 17 here. All right. A florist sells 3 roses for $1. Estimate the cost of 5 roses. And it also says to graph this. So maybe we'll do the graph first. So is the input roses or money in this problem?
The input.
Yeah, like is the way this written in terms of like, I give you the roses, you give me the amount, or I give you the amount and you give me the number of roses?
Like are the roses the input?
Yes.
Yeah.
Yes. So that's on your x-axis here. Okay, so your x-axis is sorry, let's do this here. 3 roses, $1. Okay. And we assume reasonably that if you don't want any roses, it's $0. Okay. So there's the other point on your graph. So do you see that it's rise 1, right 3?
Mhm.
So another point would be 6 roses is $2. These are certainly post Valentine's Day prices here. They're usually a lot more expensive than that. All right.
Mhm.
So we want to estimate the cost of 5 roses. So this is where you go to your graph here, hit that, and then you go left.
15. Or wait. Oh, okay, never mind.
And you're giving me the Y value here. What's the Y value?
Like 1 point.
Roughly, give me a reasonable number here. I'll tell you if it's unreasonable or not.
1.8 or 1.9.
Yeah, that's reasonable.
Yeah.
Okay, so I knew this one was unclear, so I want to give you one like this.
And yeah, it made sense. It's just I wrote the graph weird. I put it in like intervals of 3 instead of making them spread out. Yeah.
Yeah, and so spread them out here. I know I've got the grid paper that helps me, but let me give you one more like this because this is a lot like 9 or 20, so it's kind of similar to that. But let me give you one here to try. Let me type this one. All right, a grocery store sells 6 bananas for $4. Graph this relationship. How much, or estimate the cost of 15 bananas.
Bananas, $4. Yeah, so 15 bananas. And 6 per. Oh. Okay.
Sounds like you may have seen something that you didn't.
Yeah, it's just I kind of flipped the X and the Y axis. But
You can still do this correctly, even flipping it.
okay.
Okay, so keep going. I'm making a bit of an assumption that it is input of bananas to dollars. I mean, when I go to the store, that's it's actually weight, but you're not wrong. Like it's still linear, even if you go the other direction. So what do you think here? What's kind of your estimate?
I would say six, 12, 18. I mean, around Sorry, give me a minute. It's just
Yeah, take your time. Take your time. I'm not trying to
everything.
pressure you. Um,
Ahorita.
We're just trying to help.
is there anything I can answer there, David? I mean, I'm not here to make you struggle. I just,
Um, yeah, like 12 or 13 or
so a little high. I know your graphs you said is slightly different. Did you get 12 bananas cost $8 on your graph? Do you have that point? Or 8, 12, 12, 8, either way.
yeah. Like
Okay,
I put 6, 12, 18 like on the x-axis and the
okay,
y put like 4, 8, 12.
right, right. So let's just say you do it really small here. So you go 6 and 4,
Uh-huh.
12 and 8. This would be 18. Do you agree?
Yeah.
Okay, 18 and 12. Now 15 is hitting it right in the middle. Do you see that?
Oh yeah. So
So
like
your answer is a
9.
little, yeah, maybe 9, 10, somewhere in there would be good.
10.
So it's okay. It's okay if you don't have like, go count them out. You can still, as long as you're consistent on each axis. And like I said, just go up and hit it and go left or hit it and go down, whichever way you like.
Yeah. So I just have to format my graph like that.
It
I
is
mean,
good. But here's the
yeah.
thing, it doesn't matter if you were backwards. And when I say that, I don't literally mean like, but if you're like, okay, dollars, 4, 8, 12, 6, 12, 18, it's going to produce exactly the same answer.
Uh-huh.
15, hit it. Do you see that?
Yeah.
So it doesn't matter which way you graph it. Just be consistent with your units, your increments there.
Okay, yeah. I think I was just randomly like having a brain fart.
That's okay. That's okay. Let's move on here. We got plenty of other stuff to cover. For 18, there's another formula that you need. 18 is the range. Range is the max minus the min.
Uh-huh.
Okay, so let me actually really quickly grab a question here for you to find the range. Sorry, none of these actually have any. Okay. Let me look at one more. I'll just make it up. So data set A is 2, 5, 7, 3, 4, 1, 9, 11. B is 1, 1, 2, 2, 3, 3, 4, 5. Give me the range of A, the range of B.
So A is 10 and B is 4.
Very good. Now you might get a problem with a stem and leaf plot, so we should talk about that. So let's say it's some sort of stem and leaf plot like this. 0, 1, 2, 3, 4, 3, 5, 7, 0, 8, 9. And let's say it tells you the legend is 4/1 means 4.1. Okay, that's the legend on here. What is the range of this stem and leaf plot? Okay, so you have to use the legend to figure out the biggest number and the smallest number.
Well, does the legend only apply for 4, or does it apply for like 3.1?
It applies to everything. Like they're trying to give you enough number to tell you that the number on the left is the whole number, the one on the right is a decimal.
Okay. So is it like 2.9?
Yes. So 5.9 minus 3.0 is 2.9. Let's have you do one more range. Just because this has got more of a data set. I want you to scan through it here. Tell me the max or the min when you look at this, something like this.
The max is 499.15, and the minimum is 200.
Keep going.
277.90.
Good. Now, the nice thing about this one is that it was in order. Sometimes they're in order, sometimes they're not.
Yeah.
All right. So let's jump back to the previous page here. Let's do some like 19 here. So let me first start off by giving you, let's say I wrote something like this, y equals minus 2x plus 1. The slope is always the number in front of x. And the b value, the intercept, is always the other number. So the slope for this problem is -2, and the b value is 1. Okay. Slope is the number in front of x. The b value is the other number. Is that okay?
Yeah.
Now, what you're going to be given is something like this: minus 3x plus 4y equals -12. Notice that it is not in this format up here. So you first need to solve for y. Okay, you got to be very careful with your signs, moving things around. Do you want me to show you how to do this, or do you want to try this on your own?
Let me try it first, and then we can
Okay.
see.
Sounds good.
So y is equal to 3 plus 3x divided by 4.
Okay, so just be careful here. Let me show some steps here. So it's 3x minus 12. It's better to put the x in front. And then when you divide by 4, you're dividing both by 4. And you want to show it that way. You want to show the separation between the two. So 3/4x minus 3, like that. Maybe that's what you had and you just said it slightly different. But if you didn't, please divide both of them.
Well, kind of. Well, not really. What I said is y equals 3x over 4, but not 3/4 x. So
That's okay. 3x over 4 is fine. And then as long as you said -3, that's okay. I didn't quite hear all that.
it was a +3, so I think that's what got me.
Okay, because it's a negative divided by a positive, still negative.
Uh-huh. Oh yeah, okay, I see.
All right, now that we're at this position here, what is the slope and what is the b value of this?
The slope is 3/4.
Good. It's always the number in front of x, and the b
Yeah.
value is the other.
Yeah, -3.
Good. Okay, I'm gonna give you another one to try. Any questions though on this, or
No.
all right? Let's go -5x minus 6y equals 30. I want you to solve for y, and then I want the slope and the b value.
Okay. Okay. So I got y equals -5 6x plus -5.
Like this, or you said plus -5 at -5.
Yeah, -5 basically.
Good. Looks good to me. What is the slope? What is the b value?
The slope is -5 6, the value is negative, or just -5.
Good. Excellent. Okay. Let's do a graphing, solve by graphing.
Okay.
I will make this relatively simple since I know graph. Do you have, if you had graph paper, that would be ideal.
I do have graph paper. I was just messing up on the graph.
Oh, good. Because I think it's kind of unfair to be like, all right, here you go, make your graph, and you're working on line paper or something. All right, this one does have a nice solution. Do the best you can here. You need to identify the slope and the b value of each. That's a good starting point. And then graph them. You always start with the b value to graph.
Uh-huh. Wait, so I find the
What's the slope of the first equation?
slope is 4,
Okay, and the b value is
3.
3. So you start by going to the b value and then graphing it. Now this one's a little odd because you can't go up and to the right. You can sort of, guesstimate it, but you can also go backwards. Have you guys talked about that in class?
Uh-huh.
Like you try to figure out the point such that if you go up 4 and right 1, because the slope is really 4 over 1, you get back to this point.
Yeah. So does the B represent the intercept.
Yes, that's exactly what it is. It's the y-intercept.
So then we can graph the line with the slope.
You put a dot on the y-intercept and then you move from there with the slope. And what it's trying to point out is like this one's off the graph, so you don't really want to use that point. You want to go find another point, go in the other direction. Like see how from this new dot, if you go up 4 and right 1, you get to the
Uh-huh. Like if you go up 4 and right 1.
you get back to that point. Because you don't really want to graph something off the
Yeah. You want to keep it on the line.
all right. And so you do the same thing for the other one there.
So like -1 and the intercept is 2 or negative.
-2, yeah. Now the slope is better written as a fraction, -1 over 1. And that means down 1, right 1.
Down 1, right 1.
Yeah.
Okay.
Any questions on that?
Well, like what was like if it asks you to solve by graphing?
Yeah.
That's what we did.
Well, we haven't figured out the intersection, but I'm trying not to, because as soon as I draw it, you'll have the solution. So what I'm trying to do here is not give you everything, but you have a line through those points. Do you see that?
Yeah.
And then you similarly have a line through the blue points. And you're supposed to figure out where they intersect.
-1 or -1.
Yeah. Like that.
Okay. It makes sense. I was just having trouble graphing them like both of the lines respectively. But
All right, let me see if I can give you one more here. Yeah, this is good here. So here's 2 other equations to solve by graphing. Kind of incorporates everything we've been doing in the last couple of problems here. Okay. All right, so there's your two equations. Notice that these are not in slope intercept form. You have to solve both for y.
okay.
Okay, so that's what I'd like you to do first, to solve each of these for y. Make sure we got that correct.
So the first one, like -y equals 1 minus -2.
So the first one, -y equals -2x plus 1, but then you have to get rid of this negative.
Oh,
Like you can't leave a negative in front of y, so you divide everything by -1. So what does that become?
Y equals -1 or
It is -1, but that the number is best to come second. What about the -2x divided by -1?
that goes before
Yeah, and what does that, what are two negatives dividing, what does that become?
x.
2x. The negatives cancel, just like they cancel over here on the left. And again, it's better to put the x term in front. Really is. Really like be better long term. Okay. Go ahead and try this second one here. The second one's a little bit easier.
Plus x. So y equals x plus 2 or 2 plus x.
Yeah, but again, preference is to write it this way. Okay, so I'm going to grab these equations, rewrite them down here, kind of reframe the problem here a little bit. What I want you to do is for each equation, tell me the slope and the b value.
So for y equals 2x plus 1, the b value is -1, the slope is 2.
It's 2x minus 1. I think as you said +1. We should probably go back and look at that if that's not consistent.
Wait, so
Let's go back and look. You said because you're this equation on the left, you're subtracting 2x from both sides. That was the -2x plus 1. And then you're dividing everything by -1.
oh, so it's just 1.
Well, 1 divided by -1 is -1.
Yeah.
Okay, I heard +1 here. Maybe I misheard.
No, yeah, that's I thought I said -1. But
That's okay. So the slope is 2, but we really write it as 2 over 1. The b value is -1. What about for the next one here? What's the slope and the b value?
the slope is 1, and the b value is 2.
Good. All right. So go ahead and graph both of these and see if you can determine the intersection. It is a nice point.
Graph the intersection.
Well, again, okay, so yeah, I want you to graph each of them. So you start with the b value. Start with -1, for example.
Yeah, that's
And
the
then that's the intercept. And then use the slope 2 over 1. So you go up 2.
up 2 over 1.
Yes. Up 2 over 1. Okay, and you can go for a while if you want.
2 over 1. Okay, well, there's 1, and the second one, it's 2 and up 1 over 1 for the second one.
Yeah, so the second one here, I'll do in a different color. Up 1 over 1, up 1 over 1, and you can see they're converging.
So on 3, 5. So 3, 5 is the intersect.
Yes, very good.
Okay, that makes more sense to me now.
All right.
We don't have to do 20. It's not that difficult if you don't.
Yeah, I was just trying to decide, is there better use for time? I did not give you one like 14, so let's do that. I'll type that here. All right, so the sum of a number and 25 is greater than -16. Could you
Uh-huh.
convert that into a sentence inequality?
Like 25 plus X is greater than -16.
So I'm going to write what you said, and you just confirm that that's actually what you meant.
Yeah, that's
Okay,
right.
and that is correct. Okay,
Okay.
so let's do another one. Let's do another possibility. The product of -3/4 and a number is less than or equal to 2/5. I'm sorry. Yeah, like that.
To 1/5. Okay. Less than. Okay. So -3/4 X is that's less than or equal to 1/5.
Yes, like that.
Yeah.
Good. All right. That'll probably do it for us for tonight. You said your test is tomorrow, is that right?